Hello, my name is Okada, and welcome back to Pixel Perfect, episode 62. This will be the first episode of the new year. Yeah, I took a week off. I was going to do something over the New Year's, but then I didn't because it was the New Year's, and I wanted to spend a little time doing some other things. But I am happy to be back, and happy to have you back with me. And I hope that everyone is as eager as I am to see the continuation of our turbo motor mega project. Because today we are ready to move on to actually belting up the entire building. And I mean belting it up. There is so much logistics to be done. It is crazy. It's going to take so many hours. Originally I thought about doing it on live stream, but once I got all the machines down, I really got the grasp of just how much is going to have to be done with all the belting. I thought, I just can't really do that all in one live stream. So I decided to do it in an episode, probably do a little bit of montaging and just knock it out. So today we're going to try to be as focused as we can on just doing the conveyors, which might not sound too exciting, but then again, you're interested in watching videos about building factories, so I have to assume that you like the logistics part of it as well. But in the interest of keeping this video at a reasonable length, I'm going to go stock the train and head out to the job site. I'll see you guys there. All right, here we are back at the job site, and there's a lot to be done. Today's going to be all about the logistics, and to be honest, the logistics in a scenario like this could be rather daunting. You can see we have several floors. I think, 7 floors, and then we have 2 buildings, so effectively 14 floors. And when you consider the size of the project, right, we're talking about a bunch of different machines that all require different things and different floors, and there's going to be conveyors going everywhere and pipes, and it all has to work in harmony because they all have a single goal, which is of course turbo motors. So figuring out where everything's going to go can definitely be daunting and a little overwhelming. And well, what we want to do in a situation like this is to start tackling things kind of piecemeal. We start by looking at things that have very obvious solutions and eliminate those from a list of things that we need to tackle. And then we can start connecting machines together in their groupings, which will allow us to determine what our options are for inputs and outputs for the machines and where they might come out. And then we can start to look to the best way to connect those with the source. So when I say, we can look at the things that have kind of obvious solutions. We can start with things like the train stations. So if we look at kind of what we've done over the most recent live streams and in last episode, we have finally, established where our train stations are going to be. And not only that, we have established what's going to be on the stations. And that's a big help. Once we knew what was going to be in each building, because we had all the machines placed, we set ourselves a little sign here as a reminder. This building's going to need coal, water, and nitrogen. And if we go all the way over here, Building 2 has iron, copper, deuterium, fuse modular frames, and radio-controlled units. And based off of that knowledge, we were able to, again, establish what we're going to do with the trains, and that really helped things out a lot. So let's look over here real quick. We're going to have fewer objects on this side, so let's focus on this one. Nitrogen, pretty simple. And, we have 2 trains coming in, or 2 carts coming in on the train that are going to have nitrogen on them. And this is going to be in gas form, which means we don't have to deal with head lift. We don't need any pumps or anything like that. All we need to do is just bring them right up. That's super simple. And we set these towards the outside because I don't want to have collision between the freight platforms because we don't have a lot of space between them. Now, it would work out if we had them facing each other, but it'd be a little cramped, right? And we kind of want to have as much open viewing space as we can. And if we had, say, a lift coming out and going up and a lift coming out and going up, we wouldn't have a whole lot of space. Plus, if we were walking through here, it'd be a little tight. So as a general rule, we're going to attempt to keep these, kind of facing away from each other. So in this case, right, we have a fluid platform facing that way, and this freight platform could, it can be back to back or front to back. And that's going to give us, kind of our options for what direction we're going to go in. So if we look here, you can see we've color coordinated. And let's look at this here. The building 1 again, coal, water, nitrogen. We have nitrogen over there. We earmark this for water, which again is going to be its own station because we have the bottled water loop going on. Yeah, it's unnecessary, but it's fun. And that means we have to have one station for the bottled water coming in and one station for the empty bottles going out. And we could have bottled them on site, but that's kind of really pointless then. The advantage that we have here of doing bottled water is that we don't have to deal with pumps again. So we don't have fluid dynamics are not an issue because we can conveyor lift the full bottles up and then bring the empty bottles back down. So that's going to make things super simple, but that means we are dedicated to one station here for just water. And we're going to go over here to coal and Caterium. And previously we established that coal was the first car on that train, Caterium's on the second one. And we've put that in the middle because coal's going to be on that side, Caterium's going to be on that side. And now that I look at it, we have the coal platform going the wrong direction. Yeah, that's not going to work out. Now, of course, we could bring it up and then we can just conveyor it across, but I believe this building is purely coal dependent. I don't think we have any coal going over there. We have our foundries here that are going to require coal, and then they're going to go up further. Let's see here. Not that guy. This one right here is going to require coal, and I believe that's all the coal usage. So coal is going to be isolated to this building, so we want it to go up on that side. So what we're going to do is we're going to flip this station. That means we're going to need to flip that station as well. Not a big deal. Let's do that. Super easy. We will need to repaint them. Coal is black, kind of dirty. We'll give steel kind of a gray there. Go with it. And then for water, we have a nice blue. And the secondary color is not so important for that one. We'll just go ahead and do it like that. There we go. I didn't actually look at what I had it set to before, but it doesn't really matter. It's all good. All right, so, we will be bringing these up in the middle of that platform, but that's fine because this, again, is our logistics transfer floor. This entire floor is open for having containers, for buffers, and for conveyors to be able to go up and down and from side to side to be able to cross around without congesting the floors above. So this is all free space for us. And that's perfect. It's going to make things so simple, super simple. Now, again, I said starting off, we have a number of things we need to deal with, and we want to go for the things that are the easiest or have the fewest solutions, which of course would be the train stations. So let's start by grabbing ourselves a conveyor lift. I know that we're going to need faster than Mark 1 for this, but we'll come back and change that out in a bit. The output, and I'm just going to bring it up to the glass. I don't really care because we're going to go put lift holes up here, and then we'll redraw it later. And I'm going to do the same for here. What's your Caterium actually is going to be the other side. So let's swap that out here. That's kind of a faded yellow with a soft blue. Let's flip that around. I think we might have gone with that. Oh yeah, default color, nice. We don't have to customize it, excellent. And that doesn't run into a station over here, so super simple. Let's grab the output, bring it up. I said let's grab the output and bring it up. Now, if we have any situations where we need to have more than one lift coming out, we can always bring it out a little further and bring it up, or we can, dido it over a little to the side and then bring it up. That's not a big problem. We're not worried about that. But this is going to give us the alignment for the lifts. Now we can just flip over here, do a little bit of that. Super easy. Just like that. Delete. Let's grab that. And this should align. Swap the direction. There we go. Super easy. I'm not even going to bother with putting it on the top of it. Not yet. I'm going to just take care of this. Because I want to figure out where that's going to go, right? We might have it go all the way up. Or, if we have to decide that we need to maybe move it over before it goes up. That's what the logistics floor is for. But we now have established where our coal is going to come up We've established where our caterium is, and we can also grab ourselves a little sign here. These are just so helpful. If you really want to do this when you're, doing a large project, is leave yourselves little notes, just little notes, super easy. And then you can come back later on and delete them. And that way we don't have to, follow them down and figure out where everything is. We see that right there. We know that's got to go to coal. Pop over here. And same over here. We have piping coming through. And horizontal to vertical, which also makes things super easy because it will adjust itself. Yeah, that looks fine. Excellent. Excellent. Now let's go up here and I'm also offsetting these signs. You notice that they're not lined up on either side because I don't know where the belts are going to go, and I don't want the signs to be in the way. So, if we end up going out in one direction or the other, we go up, it doesn't matter. We don't have to worry about the signs being in the way. Batteries, yes. Knew we were forgetting something. Okay. The batteries need to go in to the drone station up there. Perfect. Excellent. Okay. Yeah. We just need to get all the raw stuff. It's going to be raw iron, copper, the outgoing right here. This will be the final product. This will be the turbo motors. We don't have a color set for that yet, but that's okay. Leave this alone. And we're going to head up here. I think probably the easiest thing is to look at where the batteries have to go to. Right here. Super easy, right? That's going to be the battery input. And as we look at it, maybe we should flip the batteries to the other side. Is that an option? I don't know that it is. No, it's not, because it's coming in on that train. That's okay, because we can bring it up and we can just ride it along this platform, right? We just think, whoop, we'll go backwards, right? Go through here, just like that. So that gives us our first target. Now, we don't know yet how many batteries per minute we need, and we won't until we start running the drones. So for now, we're just going to draw a super simple line here. That's middle, -2. Middle, -2. I think we're going to just kind of end it right here. And this is the process we're going to go through, is to start mapping out where we would like to connect things. And I'm not going to bother bringing it over yet. I know we can just bring that up a couple of floors, but this lets us know what our general target is. And maybe we'd bring it over or through here, or maybe we'll just cross that over somewhere else and decide to bring it straight up. We don't need to commit to that yet because we don't know where everything else is going to end up. But that's the process we're going to go through. We're going to start with each set of machines. We're going to propose a place where we can bring their outputs and their inputs, see whether or not they're going to conflict maybe with where other machines might want to be. And in the case where we have multiple options for inputs or outputs, then we can adjust them afterwards. So let's begin the big old process of just combining. Start with the iron over here. We know the outputs are coming to the middle. And decide what direction we're going to want them to go. We're going to have them merged. They can go to that side or they can come to this side. And we were talking about on this side having batteries come up. So let's have them go to the other side. And there's the output, pretty easy. We're not going to worry about mathing the belts just yet because, things could change. We just want to draw the belts. I'm going to take this right to the edge. Have it leap over. And we do want this interconnectivity. This was, part of the design. We want belts going back and forth just because we want to give life to the factory. And that means we can bring it over here and we can start connecting them to all the machines. But of course, the foundries require 2 inputs, so we wanted to make sure ahead of time we know how we're going to bring the coal in and what kind of design we want to do to have it look kind of nice, and not have belts running into each other. So I think since we have all this space to work with, what we want to do is give us a little bit of breathing room. I'm going to put this, let's do a test. Let's do a test here. What we're going to do is we're going to draw a temporary line between these. And this is our proposed iron ingot line, but we need to get belts into here without running into them. So let's see what it would look like if we were to place a stacker there and go down. Super easy, nice clearance. Now we would have, of course, coal coming in. And that's going to be too close to make that clearance, right? So let's see here. Let's try on this side, see if we can get away with this. Is this too close? It is not. That's probably going to be better for us. And we could, of course, get on the glass, but that's what we're trying to avoid doing. But also would help if we line this up right. That looks better. Okay. There we go. I think we've got ourselves a winner. I like it. So what we'll do is we'll go through here and we'll place all of our connectors. And there we go. There are all the foundries done. Of course, we still need to merge the outputs, but we now know where the inputs are going to be, and we decided to have coal code this direction, just the same as our iron ingots. And we're out of building material, but that's all right. Let's do that real quick, like super simple. Look at that, lined up automatically. Oh, that is so good. But now we know where the coal needs to come up, and we already knew that we had it over there. And that means we can decide if we want to bring it up here. I'm also reserving the right to maybe flip these in the future. Well, that would be super easy. We would just, reverse it and bring coal up on this side. And the reason we would possibly do that is because we need coal over here. But that's fine. I'm not going to worry about that right now. That's something that we can do later. This is giving us the basic structure that we need to start organizing everything. All right, let's start looking at other machines and getting things connected. And I'll bring you back in because this is going to take quite a while, and we don't need a 50-minute episode of just drawing conveyors. So I'll bring you back in for a progress update. I think we're at a good point to an update. I probably have a good 8 hours or more since the last clip of just running pipes and belts and logistics and moving machines and mathing everything, and I'm having a blast. I love it. I love doing this. This is this is part of the draw to the game for me. You can see here we have our nitrogen pipes done. We have a Mark II and a Mark I. We kind of slinked them across the ceiling of the logistics floor or the transfer floor, and we brought them up because we're using too much for one pipe to carry. So we have one machine here that's using 240 per minute. A couple more here using 240 a piece, so it's 480 per minute. So we're not maxing out the pipe. We won't have any problems with that. We have our, I believe, our steel ingot line coming up and splitting and going up to one floor and then going over to another building. Because over here we have our, our steel beams? Yeah, steel beams. And these are going to be feeding our hyper efficient steel screws. This is one of my favorite recipes in the game. I love this recipe. And it produces a ridiculous amount of screws for so few steel beams. It is so nice. So many so that we had to split those between two outputs. And those are going to go up here and supply other machines. You can see we don't have the outputs done yet. I'm not done. We've still got more to do. But this is going to be our rotors. And there's a couple of places where I needed to split the underclocking. Normally I follow a strategic philosophy that when I have a group of machines and I don't need, the full set, right? Like in this case, we have 6 machines. We only need 5 point something. Normally, we only underclock one machine. Now, not everybody does that, and there's nothing wrong with splitting your underclocking between multiple machines. But strategically for me, I tend to only do one machine, and I do the one that's at the end. So in this case, I would kind of designate this one to be on the end if these were all in one group. So normally, wherever the resources are last to arrive, that's the one I underclock. And the reason for it, again, is so that I know where the underclocked machine is if I need to look and check to see if something's been underclocked or if I need to adjust it in the future. It's entirely a strategic decision. It's not a mechanical one. I don't get an advantage for doing so from the game mechanics. But in this case, since we had to split the screws between two sides, this one is half underclocked from the total underclocking I need, and this one is sharing the other half. So we would have otherwise had one of them at 15 per minute and all the other ones at 100%, but I split it between these two. And that makes the math work out beautifully. But again, these are the last two to receive the screws, so these are the two that got underclocked. I did a similar thing over here, but for a different reason. Here, I underclocked these to 40 per minute on the steel ingots rather than 60 per minute, and the reason I did that was because if we're using a Mark I belt, which carries 60 per minute, this would never get backed up, right? It would receive exactly the amount it needs, right on time all the time. I prefer to have a belt speed that's above the expected input. So rather than move this up to a Mark II, I just underclocked both of them so that I could have a Mark I on both of them. Completely unnecessary, just kind of a symmetry there. But let's move up, actually. Let's go down, because I want to show you a change I made from the last clip. Over here is our iron ingot area. Now, I believe that we had already started doing this in the previous clip, but when I got a little further into it, I realized, it's going to start connecting the inputs, that we have iron ore coming up there. You can see we've run it into a buffer. And I figured, well, why run it across and up just to, go around the outside the way we had it when I could just run it right up the middle, flip all the machines around, and split it out that way. And so that's what I did. And it's nice and clean. And we can have all the outputs go over here and merge from both sides. And that way we don't have any belts going over or under each other. And then they can move on their merry way to be turned into steel. And we did a similar thing up here with the copper. We just brought it right up the middle instead of bringing it over to the side and over. And this is going to make our copper ingots going straight into the refineries for our copper sheeting. Merge back up and head upstairs. We have this nice hole we can fly through because the refineries are too tall. And I probably will get rid of this floor here, or maybe I'll add, another floor there. Probably not. I don't know, we'll see. This is going to be a final cosmetic pass in the end. When we go through, and I still got to do all the wiring stuff. You can see these are still floating from where the floors used to be. But I want to show you a couple more things here. Try to keep this relatively brief. If we go all the way up to the quick wire manufacturing, we got a little bit creative here with the layout. Now, previously we had already placed all these machines, and they're still in the same place. However, I got to thinking about how are we going to do the quick wire? Where's it going to go? We have more quick wire than we can do on one belt. And I started looking at, the outputs and where they need to be. And we have 3 floors of machines using quick wire. We have that floor right there, that one over there, and then the floor above it. And so what I did was I matched the quick wire production with the machines that are going to use them. So we have 5 machines here that need 60 quick wire per minute. These produce 60 quick wire per minute, so I grouped these in 5 for the 5 above us and just merged those outputs and sent them up. And I flipped these around. In fact, I think I flipped all of those around so that we could have the rest of the quick wire all merge and go up over here, run across between the buildings, and then split in half, take those 5 and up to these 5. You can see we've done all the belting. It's all nice and clean. Nothing's clipping. Oh, it is such a thing of beauty. And we still need to do the outputs. These are for the stators. I'm not worried about that right now. It's so close to the end. You can see we had probably the rotors down there that still needed to have their outputs put together. We have the stators that need to come together. And they're all going to need to come over here for our motors. That's going to be next. And we have a floor up here for our pressure cubes. Those will need to be all connected. And then the final product. So you can see how close we are to being done with all the belting and piping. Though we still have lots to go with all the wiring. We still have to do walls and windows. And we need to put another floor on top of this to give it a roof and have maybe an observation floor. And we still, of course, need to have another rail station back at home to be able to bring in the radio controlled units and the fuse modular frames that we're going to need for these machines over here. That's probably going to happen in the next episode. So I'm going to get to running the rest of this belting so we can take a quick look at it, and then we'll probably wrap it up for the episode, trying to keep it under a reasonable time. So I'll see you probably another 4 or 5 hours. Ooh, we are in the home stretch. We have, I think, don't quote me on this, I think we have everything else hooked up except for the output for the turbo motors themselves. And this has been a challenge. You know, we have so many conveyors going everywhere. Trying to find a place where things don't collide has really been something. I'm not gonna lie. And I'm gonna just go ahead and plop these down real quick like. And we're gonna connect these to the station. And then we're gonna go home. We're gonna go home and call it because we gotta get this video out. And we just turned out the wrong way, didn't we? Yeah, did we? Maybe? Maybe not. Okay, excellent. So, I want to take you on the journey to the final destination here of the last conveyor. That should go over to there. Okay, we had to get real creative with getting this out and back down because, again, you know, we've used up basically all the corners and there's just so many belts everywhere that it's just really become a logistical challenge. But I'm enjoying that challenge. And we've got a little bit creative here. So we're down, we gotta switch buildings, so we're switching over right here. And then we're coming down. Let's see here. I was still in the middle of it. I'm like, you know what? We should be recording this as I go. And okay, yeah. We gotta keep handing off because, you know, in different corners here we have things that are going up and we're avoiding like that one over there. We can't make it over on the other side. So we had to kind of wind our way around. Before we do a belt, we need to do another lift. Up here to meet with that. Excellent. Nope, we don't need a pole, we need a belt. It's, oh, so close. Okay, well, this is the middle. Let's bring it right to there. Angle so we can make sure it's lining up. Perfect. That one. And I just went through and I drew the holes so I would know, you know, like, you know, it's easier to check to see if it's going to run into anything before you just don't. You don't want to do conveyor and lift and all that stuff and then just find out, you know, several floors down that, oops, you ran into something. So it's easier just to get all the holes lined up. And then come back and draw the conveyors connecting all of them. And of course those are the conveyors going up to make the pressure cubes. And once we're down on the transfer floor, you know, we're home free. I can just do this. That. Is that gonna line up? Are we gonna get a perfect turn out of this? No, we are not. Okay. We can figure something out. Oh, let's see here. So we turn it this way, it's still going to be off. You know what? I know this is still perfect. We'll figure something out. For now, I'm going to make the connection just so that everything is officially connected, and then come back and fix it later. I think it's literally the only place in the entire structure that has an off turn like that. And we'll figure something out. We'll work it out. But that's it. That should be the entire facility is now 100% conveyored. Conveyored and splittered and mergered and the speeds, you know, the belt speeds are all mathed out everywhere. All the machines have their recipes and anything that needs to be underclocked is underclocked. I mean, of course, until we turn it all on, we won't know for sure. So, you know, that's gonna be probably next episode. It's not gonna be this episode because I still have to go through and run all of the power cords and all that stuff. But I'm gonna do that later. No, I want to get this edited and I want to get this out for you guys. So I'm gonna jump on the train and head back home. All right, that was a rather focused episode, I would say. Very focused and very productive. I mean, it may not look like it, but again, that took so many hours that I'd have to go back and look at what the original save time was for the previous episode. But I'm guessing I put in upwards of 15 hours into running conveyors and moving machines and mathing everything out and just plotting and planning. But it was a lot of fun and it's very satisfying to get it done. And I can't wait to turn everything on. But there's still a lot of work ahead because, again, we still have to run all the cables and power everything, set up the other train station that hasn't been built yet at home so that we can send over our radio controlled units and fuse modular frames, get all the train schedules set up, and actually build the facade. So there is a ton to do still. But hopefully in the next episode we can turn it on and see what breaks, because it never works completely right off the first try. But I am looking forward to it. And hopefully you are too, because I've enjoyed having you along on this mini series centered around turbo motors, and I can't wait for us to all see it completed so we can move on to the next project. But as always, thank you so very much for coming out and watching. Be sure to leave a comment. I love to hear from you guys. Leave a like if you enjoyed it, and hopefully I'll see you in the next episode. If you enjoyed this, you may want to check out one of these other videos, and thank you very much for your time.